Welcome to the podcast to Philippe, and today we are going deep, really deep into a strange idea. Like, can we make electricity from the Earth spinning?
Yeah, it's pretty wild, right?
Yeah. So we'll look at how long people have thought about this, and there's a really cool new study that has people talking about this idea again.
Oh, yeah.
And then we'll see what scientists are saying about this. Like, is it even possible?
Yeah, the reactions have been pretty interesting so far.
Yeah, and also, if you like these kind of deep dives into crazy ideas, we'd love to get to 1,000 subscribers on YouTube today.
Definitely every little bit helps.
So, yeah, if you could subscribe, that would be amazing. But anyway, so let's get into this whole earth spinning making power thing.
It's an idea that's been around for a while. Back in 1832, Michael Faraday, he was like the OG when it came to this stuff. Electromagnetic induction, like how magnets and moving wires can make electricity.
Right. Yeah, I vaguely remember that from physics class.
So Faraday, he was thinking, if we can make electricity by moving a wire through a magnetic field and the Earth is like a giant magnet and it's spinning, couldn't we tap into that somehow?
Yeah, that makes sense. Like, it's kind of like how a power plant works, right?
Exactly.
Yeah.
It's the same basic principle, but here's the thing. Faraday ran into a problem. The Earth's magnetic field, it's pretty much the same. Everywhere you go, it's uniform, and that's a problem.
Okay, so why is that a problem? I'm not sure I get that part.
Okay, so imagine you have a wire moving through this uniform magnetic field. The electrons in the wire, they start moving because of the magnetic force, but then they bunch up on one side of the wire, creating their own electric field that cancels out the magnetic force.
So it's like they hit a wall.
Pretty much. And the flow of electricity, it just stops. You don't get that continuous current you need to power anything.
So that's the roadblock Faraday hit.
Yep, that's the one.
Okay, so fast forward to now, and we've got these researchers from Princeton, and they're saying, hey, maybe we found a way around this problem.
Yeah, they published the study in Physical Review Research, and it's got everyone buzzing.
So what did they do differently? How did they crack this nut that Faraday couldn't?
So they got clever with the materials and the shape of their device. They built this hollow cylinder out of this special magnetic alloy. It's got manganese, zinc, and iron in it.
Huh. Interesting choice. Why that particular mix?
Well, this alloy, it has these special magnetic properties, and the hollow cylinder shape, it's crucial because it creates this kind of pathway for the Earth's magnetic field to interact with the device in a unique way.
Okay, I'm starting to see the picture. So it's not just a random wire anymore. It's this specially designed thing.
Exactly. And they did a ton of calculations and figured out that with this specific shape and material, the magnetic forces wouldn't be completely canceled out by the electric ones.
So they found a loophole in the system, basically.
Yeah, you could say that. So they built this device, and then they had to be super precise about how they set it up.
Oh, I bet. And I also read that the angle of the electrodes was really important, too.
Oh, yeah, that was key. They set the electrodes at this very specific angle, 57 degrees to be exact, and they made sure they were perpendicular to both the Earth's rotation and the lines of its magnetic field.
Wow, that's some serious attention to detail.
It had to be. They wanted to make sure they were measuring the actual effect of the Earth's rotation and not some other random interference.
Right, makes sense. So what happened? Did they actually get electricity out of this thing?
They did. It wasn't a lot, just 17 microvolts.
17 microvolts. It's tiny, right?
Yeah.
Like barely anything.
Yeah, to put it in perspective, you would need millions of these devices to power a single light bulb.
Wow. So not exactly a power plant replacement.
Not yet, but hey, it's a start. And the fact that they got any electricity at all, it's pretty remarkable.
So what's the scientific community saying about this? Are they excited? Are they skeptical?
Well, it's a mixed bag. There are people like Paul Thomas. He's a physicist at the University of Wisconsin-Eau Claire, and he was pretty impressed. He said the experiment seemed really well done, and the results were intriguing.
But I imagine there's some doubters, too.
Oh, yeah, definitely. Like Renke Weingarten, he's a retired physicist from the Free University of Amsterdam, and he's pretty cautious. He pointed out that 17 microvolts is so small that it could be caused by a bunch of other things besides the Earth's rotation.
Like what kind of things?
Well, he said there could be tiny temperature differences, vibrations, electromagnetic noise, all sorts of stuff that could create a tiny voltage.
So basically, it's hard to be sure that they're actually measuring what they think they're measuring.
Exactly. And he also suggested a really important next step. They need to test this device at different locations on Earth, different latitudes.
Ah, I see. Because the effect of the Earth's rotation should be stronger or weaker depending on where you are.
Right. So if they see a change in the voltage with latitude, that would be strong evidence that they're onto something.
Okay, so let's play pretend for a second. Let's say they do more experiments and they confirm that this thing actually works. And let's say they can somehow scale it up to produce a usable amount of power. What kind of impact could that have?
Well, it could be huge. I mean, imagine a clean, renewable energy source that's available pretty much everywhere on Earth.
That would be incredible, like a game changer.
It would, but there's a catch. There's always a catch, right?
Oh yeah, what's the downside?
Well, if we start extracting energy from the Earth's rotation, it's going to slow down a little bit.
Wait, really? Are you serious?
Yeah, but don't worry, it's not going to be anything drastic. The researchers calculated that even if we powered the entire world with this technology, it would only slow the Earth's rotation by like 7 milliseconds per century.
7 milliseconds, it's like nothing.
It's a drop in the bucket, and it's actually less than the slowing effect caused by the moon's gravity.
Oh, wow. I didn't know that.
Yeah, the moon is constantly tugging on the Earth, slowing it down little by little.
Huh. So we're already dealing with a cosmic brake pedal.
Pretty much, but hey, it's taken billions of years for the Earth to slow down to its current speed, so a few milliseconds here and there, not a big deal.
Okay, so it sounds like this Earth-spinning power thing, it's a long shot, but it's a fascinating idea, and who knows, maybe someday it could be a real thing.
Yeah, that's the beauty of science, right? Always pushing the boundaries, exploring the impossible.
And this study, it really shows how important material science is. Like if they hadn't found that special alloy, this whole thing wouldn't have worked.
Absolutely. It's a great example of how new materials can unlock new possibilities.
So what do you think? Is there anything else out there? Like this, some other crazy idea that could revolutionize energy production?
Oh, I'm sure there is. It's just waiting for someone to discover it. You know, maybe it's harnessing the power of ocean waves or using bacteria to generate electricity, or who knows, maybe we'll figure out how to tap into the energy of the vacuum.
Wow, and that's a thought. The energy of empty space, that's mind-blowing.
It is, and it's not even science fiction. There are theoretical physicists who are seriously studying that stuff.
Well, that's definitely something to ponder. So for all you listeners out there, keep your minds open, keep questioning, keep exploring, because you never know what amazing discoveries are waiting to be made.
Absolutely. And remember, sometimes the craziest ideas are the ones that change the world.
Couldn't have said it better myself. Well, on that note, thanks for joining us for this deep dive into the world of Earth-spinning power. We'll see you next time on Le Podcast de Philippe.
It's been a pleasure.